Hello and welcome to the video for notes number 4. These notes are for raising a power to a power. So we're continuing to learn about our exponent rules. These first 5 examples that you see at the top of your notes, you should be on notes 1-4. These are really all review problems. We've done these types of problems before. So I'm actually going to do one of these with you right now, and then the other ones I'd like you to try on your own and check your answers. So what I'd like to do with you right now is question number 3 here. In number 3, we have 3x to the 4th times 5y cubed times 6x to the 6th power in the numerator. All of that divided by 2y times 3x squared times 5y cubed. So what we're going to do is first simplify the numerator. I'm going to multiply what we have in the numerator, and I'm going to multiply the numbers together. These are called our coefficients. When I multiply the coefficients together, I have 3 times 5 is 15. 15 times 6 is going to be 90. So I have 90. And then I take a look at the variable expressions that we have. So here, in terms of the variables, I have x to the 4th, and I have x to the 6th. So x to the 4th times x to the 6th is going to be x to the 10th power. Then I have just y cubed. There is no other y in the numerator. So this is just going to be y cubed. Then we have to simplify the denominator. Now that we're trying to simplify the denominator, I'm going to do the same thing. I have 2 times 3 times 5, which 6 times 5 is going to be 30. Then I'm going to see here I have x squared, but that's it. There are no other x's in the denominator, so this is going to be x squared. And then I have y times y cubed. When there's no exponent, that just means an exponent of 1. So y to the 1st times y cubed. I'm going to add the exponent, so I'm going to have y to the 4th power. So now that I've simplified the numerator and the denominator, now I can divide them. It's numerator divided by the denominator. So when I divide this expression, I like it vertically this way because they're lined up. 90 divided by 30 is 3. X to the 10th divided by x squared. When I divide like bases, I'm going to subtract the exponents. And then the same thing with the y. Y cubed divided by y to the 4th. I'm going to subtract the exponents. 3 minus 4 gives me negative 1. Don't worry about the fact that it's a negative exponent. In the next lessons, we're going to get into that, but for the moment, you can just leave it like that. So the simplified answer is 3 times x to the 8th times y to the negative 1 power. So now I'd like you to press pause for a moment, try the other examples 1, 2, 4, and 5, then restart the video to see your answers. Okay, now that you've had an opportunity to try these problems, please check your answers. You should have gotten 4 squared for number 1 as a final answer. Number 2 is 1/4 raised to the 3rd power. Number 4 is 6 raised to the 2nd power. Number 5 is 3 times a to the 3rd power times b to the negative 1 power. And I did show my steps, so if for any of the questions, if you have a different answer, please check your steps and make any corrections that are necessary. Okay, now that we have completed the first 5 exercises, let's get started with the new exercises for today and the pattern that you need to observe. So in question number 6, it says, what does 2 to the 4th raised to the 3rd power mean? Well, here we have a power raised to a power. So we know that 2 to the 4th, what that means, and then it's raised to the 3rd power. That means we have to do 2 to the 4th times 2 to the 4th times 2 to the 4th. So it means to do 2 to the 4th to itself 3 times. Well, let's simplify this. We know that if you multiply like bases, you can add the exponents. These all have the same base of 2, so let's add the exponents. 4 plus 4 is 8, plus 4 is 12. So this is equivalent to 2 to the 12th power. Okay? Well, let's take a look at number 7. What does n squared raised to the 5th power mean? Well, it means we're going to do n squared multiplied to itself 5 times. N squared times n squared times n squared times n squared times n squared. And now let's simplify this. We all have the same base, that's n. If they have the same base and you're multiplying, you can add the exponents. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. So n to the 10th power. Okay, so let's go look back at these two examples. What do you notice about the final exponent compared to the original question? Well, in number 6, I see that the original exponents were 4 and 3, and the final exponent was 12. Well, 4 times 3 is 12. And then in number 7, the original exponents was n squared raised to the 5th power. The final exponent was 10. Again, 2 times 5 is equal to 10. So what I notice is that the final exponent is the product of the original two exponents. So what I've written here is that the exponent in the answer is the product of the two original exponents. Product meaning the answer when you multiply. So when you raise a power to a power, and you write it out the long way, you see that instead of writing out the long way, you can simply multiply the exponents. So down here in our answer box, it says when you raise a power to a power, keep the same base and simply multiply the exponents. So I can simplify this expression here to say it's going to be a raised to the m times n power. Now that you've seen that if we're raising a power to a power, all we have to do is multiply the exponents, let's try some of these examples. So let's take a look at question number 9. We've got 15 raised to the 3rd power, and then all of that raised to the 9th. So all we have to do is multiply the exponents here, and we will have 15 raised to the 27th power. And that's simplified. Now let's jump to number 11. And I'd like to do number 11 because the base is a variable instead of an actual number, but it doesn't make any difference. We have a to the 17th power raised to the 4th power. So all we have to do is multiply the exponents. So this is a to the 68th power. 17 times 4 is 68. That means we're going to multiply a to itself 68 times. Okay, now let's try number 12. In number 12, it's a little bit different because inside the parentheses, we have 3 squared times 7 to the 4th power, and then all of that raised to the 5th power. Now, typically, we have to do what's inside the parentheses first. However, we cannot combine 3 squared times 7 to the 4th because they do not have like bases. One has a base of 3, the other has a base of 7. But what we can do is we're going to raise everything to the 5th power. So what I'm going to do is I'm going to rewrite this as 3 squared raised to the 5th power times 7 to the 4th raised to the 5th power. So we're going to raise each of those parts to the 5th power. Now this we know how to do. If we have 3 squared raised to the 5th power, power raised to a power, we're going to multiply the exponents. We're going to have 3 to the 10th times 7. I'm going to multiply 4 times 5, and I'm going to get 20. So this simplifies to 3 to the 10th times 7 to the 20th power. And again, we cannot simplify that further because 3 and 7 are different bases. Okay, so what I'd like you to do now is to go ahead and try the rest of the problems on this page. Take your time. We're using the product, the power to a power, so we're going to multiply the exponents. But there are some times we're going to use some of the rules that we learned before about product and quotient rules. So if you're multiplying like bases, you would add the exponents. If you divide like bases, you would subtract the exponents. So go ahead and try the rest of the examples on this page. Press pause. And then once you've tried all the problems, you can start it up again, and I'll show you the answers that we have here. Okay, so let's check out some of the answers here. The answer for number 10 should be -2 raised to the 40th power. And please be sure that you've included the parentheses around the -2. And number 13, each of those, A, B, and C, will be raised to the 4th power. So it'll be A to the 8th, B to the 4th, C to the 12th. Now in number 14, you need to do what's in the parentheses first. So the brackets are just like another set of parentheses. So one way that I did it is that I chose to do simplify inside the parentheses first. So I did this part in here. 4 squared, -4 raised to the 2nd power times -4 raised to the 3rd power. When I multiply like bases, I'm going to add the exponents. So that's how I got -4 to the 5th power. So -4 to the 5th power raised to the 6th power. Now I'm raising a power to a power, and I multiply the exponents. So my final answer will be -4 to the 30th power. Okay, the same thing happens in number 15. First, I'm going to simplify inside the parentheses. So I'm going to add those exponents to get m to the 6th. Then m to the 6th raised to the 3rd power, I multiply and I get m to the 18th. In number 16, there are a couple steps going on. First, you want to simplify the numerator. I did 6 to the 4th times 6 to the 3rd. So you're going to add those exponents to get 6 to the 7th. Then you raise that to the 4th power. We're raising a power to a power, so we end up with 6 to the 28th in the numerator. And then in the denominator, we just multiply the exponents, and you're going to get 6 to the 10th. So now to simplify this, when we divide like bases, you're going to subtract the exponents. So the final answer will be 6 to the 18th power. Again, number 17 is a similar example where we have to do a few steps before you get to the final answer. So first, I simplified what's inside the parentheses. They both have the same base, so I added the exponents, and I ended up with a to the 6th raised to the 4th power. And instead of writing the divided by symbol, I just put it as a fraction form, so divided by 2 times a to the 8th. I simplified the numerator to get a to the 24th divided by 2a to the 8th. And then in the numerator, when there is no number in front of the variable, it's just as if there were a 1. So it's just like 1 divided by 2. You can either leave the 2 in the denominator and then subtract the exponents for the a's, 24 minus a to 16. So you can either write it a to the 16th divided by 2, or another way to write this one would be 1/2 times a to the 16th power, where the 1/2 is a coefficient out front. Okay. Now that you've checked these answers, I didn't want to give all the answers because I wanted to be able to go over questions 15, 16, and 17. Why don't you go ahead and pause the video again, give yourself a minute to try 18, 19, and 20 again to see if you did it correctly. Go ahead and pause. Okay, so now let's check the last few answers. So you see the answer for number 18 is 6 to the 32nd power. And I've shown my work to show you how I got there. 19 is x to the 6th power. And number 20 is 113 to the 6th power times 37 to the 3rd power times 51 to the 12th power. Okay? So then the last two, 21 and 22. In 21 it says Tim thinks that a cubed raised to the 2nd power is equal to a to the 5th. Is he correct? No, he is not correct, because when you raise a power to a power, you should multiply the exponents. And actually, if I even wrote it out the long way, a cubed raised to the second power means a cubed times a cubed, which you add the exponents, it gives you a to the sixth. So that would be a to the sixth, not a to the fifth. And then the last one, it says express, let's see, what number is that? 100 billion in exponential notation. Well, if you use a pattern, you know that 10 squared is 100, 10 cubed is 1,000. And if you continue this pattern, 10 to the fourth will be 10,000. So the exponent is equivalent to the number of zeros that you see. So 100 billion will be 10 to the 11th power, because you can count out 11 zeros. And you can try it out in your calculator to see if it works. So then part B says, how many times bigger is your answer from part A than 10 to the fifth? Well, to see how many times bigger something is, you see how many times it can go into it, which means you're going to divide them to see how many times it can go into it. So 10 to the 11th divided by 10 to the fifth, they have the same base, so we can subtract the exponents, so it comes out to be 10 to the sixth. Okay, if you have any questions, please make a note of them, and you can bring them to class so we can talk about it then. Thank you very much.